Hi, welcome back to General Chemistry 1. This is Dr. Fang Xu, and in this video, we're going to talk about sigma and pi bonds. Okay, so what is a sigma bond? In the previous video, we briefly touched about the valence bond theory, and that requires a maximum overlap of bonding orbitals. So there are a few ways for the bonding orbitals to maximum overlap. One way is called sigma bonding. So in this way, the bonding orbitals are overlapped in a head-to-head format. And the highest electron density is along the bond axis. So let me give you an example. This is ethane, right? We have carbon-carbon connect to each other with a single bond, and carbon-hydrogen connect to each other with all of a single bonds. So with carbon-carbon atoms, it has, of course, sp3 hybridization. And then we have the lobe from the left carbon and the lobe from the right carbon. They overlap through a head-to-head geometry. It's like the CH bond, the sp3 lobe, head-to-head overlapped with the s orbital, the lobe from the hydrogen. So this head-to-head overlap is called sigma bonding. And you can see this sigma bonding exists in these single bonds. Besides sigma bonding, there's another type of bond called pi bond. So unlike before's head-to-head, the pi bonding is side-to-side overlap of bonding orbitals. Instead of one good overlapped region, one good lobe, here in pi bond, we'll see two regions or two lobes of electron density, one above and one below the sigma bond axis. Pi bond does not exist by itself. It has to be accompanied by the sigma bond. Okay, the two electrons in one pi bond occupy both lobes. So here, if we have an ethane, we have a CC double bond here in the center. So we know CC double bond has the sp2 hybridization. So in the plane of this screen, we have the sigma bond, the CH sigma bond here, and also CC sigma bond here. Also, there is one p orbital that does not involve in this hybridization. So it's a 2p orbital that is vertical in this direction. So both of the carbon has that 2p orbital. So when these 2p orbitals join together side by side, there is an overlap of lobes of the top lobe of 2p orbital and lower lobe of 2p orbital. And when they have this overlap of the 2p orbital, they form this pi bond. Each pi bond have two lobes, one above the sigma bond axis, one below the sigma bond axis, the carbon-carbon bond here. So that corresponding to the double bond. You probably have already noticed that the type of sigma or pi bond corresponding to the type of bonds in the chemical formula. If we have a single bond, then it's a sigma bonding. If we have a double bond, one is sigma bonding and one is pi bonding. So that allows us to count how many sigma and pi bonds are there in a molecule. And one thing I have not touched before is what about the triple bond, right? The triple bonding includes, one sigma bond and two pi bonds here. So to summarize, a single bond contains one sigma bond. A double bond contains one sigma bond and one pi bond. A triple bond contains one sigma bond and two pi bonds. So in other words, counting sigma and pi bonds is counting the single, double, and triple bonds. How many of them are there in the molecule? All right, let's take a practice. So when we solve the sigma and pi bonds problems, we need to follow a few steps. First, write the Lewis structure of a molecule. Then you can determine the number of a single, double, and triple bond. And then you can determine the number of sigma and pi bonds. Okay, so for example, determine the number of sigma and pi bonds in SO3 molecule. You may stop this video, take out a scratch sheet, and try to figure out the problem yourself first. Okay, Let's follow these 3 steps. First, draw the Lewis structure of SO3. This is our previous chapter's knowledge, so I just skip it here. We draw the Lewis structure of SO3. The S has, in all of these molecules, so S has 1 single bond with each of this oxygen, and then has a double bond with the 3rd oxygen. So step 2 is count how many single, double, and triple bond are there. So we have 2 single bonds and 1 double bond. And then because each single bond has 1 sigma bond, and each pi bond, each double bond has 1 pi bond. So in total, we would have 3 sigma bonds and 1 pi bond. Just a brief recap. All bonds, single bond, triple bond, and double bond, all of them contains 1 sigma bond. And leftover bonds will be filled in by pi bonds, if that can make your memorization a little bit easier. All right, this is the end of this video, and I'll see you next time.